Bismillahirrahmanirrahim. Assalamu alaikum. We are doing direct and indirect proportions, and in the last session we were discussing indirect proportions, and the discussion was that if we have two quantities, if one quantity is increasing, other is decreasing. And we said that because of this relationship, that one is increasing, other is decreasing, we name this relationship as inverse proportion. And when we were writing it mathematically, so we took it as y is equal to y, or y is proportional to 1 over x. So because of 1 over x, so it's inverse. So there is more to it. What we can say is that it's not only that if one quantity is increasing, other is decreasing, there is a little bit more. And when we are drawing a graph of this inverse proportion, we'll be in a better position to understand what is more to it, which helps us to understand that it's a inverse proportion, right? So let's take another example of current and resistance. Like I'm talking about electric current and resistance. So just taking the things simple, this electric current is inversely proportional to the resistance, right? If there is more resistance, current in amperes is less. If the current is higher, the resistance is less, right? So let's take this example, and then we'll be drawing a graph of this example as well, and then I'll let you know that what is more to understand, which is also applicable in the direct proportion as well. If we understand that thing, it will be helpful for us to understand that direct and inverse proportion in a better way. So let's take that example. So what we can do is, let's assume that if we are representing current with I is inversely proportional to 1 over, and we are representing resistance with R. Okay, so current is inversely proportional to resistance. And to remove this sign of proportionality, we introduced a constant, right? And that constant is determines the relationship between the two entities, and through which we understand that what is actually the relationship in increasing or decreasing, right? So I is equal to K over R. Okay, so now we have this equation, and if we have some initial values, suppose initially we have resistance is equal to 0.5 ohms, resistance is in ohms, and I is equal to 10 amperes. Okay, so let's find out what is the value of K. So 10 is equal to K over 0.5, and so K is equal to 10 into 0.5, so it is 5. So our connecting equation is 5 over R. So this is connecting equation. Connecting equation, that is connecting I with R, having a constant which is equal to 5. And this 5 is basically determining the relationship between the current and the resistance, which after drawing the graph, I'll let you know what is happening. Okay, now since we have to draw a graph, so let's have some more values, and we'll use those values in drawing the graph. Okay. So I'm going to take resistance on x-axis and current on y-axis. Okay. So R and I. So we have already calculated 0.5, it's 10. What will happen when it is 1, 1.5, 2, 2.5. Let's take two more values, in fact 3 and 3.5. Okay. So it is when it is 1, it is 5. And how we are doing that? So we have this relationship, and if we apply it, I is equal to 5 over 5 is equal to 1, right? So when it is 1.5, we will have the value 3.3. When it is 2, it is 2.5. When it is 2.5, it is 2. So for 3, it is 1.6. And likewise, we can calculate. So for 3.5 as well. So what is happening actually? You know, why I said it's not only that one entity is increasing and other is decreasing. There is something more to it. What is it? And the more thing is that the product of coordinates, any coordinate, I mean, these two are the coordinates, value of I, value of R and value of I. Value of R, value of I, these are the coordinates. So the product of any two coordinates is going to give us the same result. So if we multiply this, it's 5. Multiply this, it's 5. If we multiply these, it's going to be not exactly 5, but it is going to be close to 5. But this is 5, this is 5, right? So this, we are getting the same results, right? We can also multiply even these. What is it? 3.3 and 1.5, so 15 and 1, 16, 33, 5, 9, 4. So it is 4.95. So it is pretty close to 5. You see, so this thing is giving us more confidence that the relationship, the connecting equation which we have, so these are inversely proportional, because you're always going to get the same result, which is going to be equal to this constant, which is establishing the relationship between the two entities, right? So now I'm going to take this chart and I'll be calculating, drawing a graph for R and I. So let's do that. Okay, so we are going to draw a graph. So we have taken current in amperes on the y-axis and resistance on the x-axis, right? It's the same chart. For 0.5, the value for the I is 10, so we are taking this point, okay? When the resistance is 1, the current is 5, so we're going to take this. When resistance is 1.5, the current is 3.3, so it's 3, then 1, 2, and this is 3. When distance is 2, 2.5, here it comes 2.5. When resistance 2.5, it is 2. When 3, it is 1.6. When 3.5, it is 1.4. Around here, somewhere here. Okay, so I'm going to join these lines. So you see the graph for the inverse proportion. It's a curve too, but in case of direct proportion, it was passing through the origin and it was a straight line. So it was giving us the trend. So both the things are increasing. But in this case of inverse proportion, this graph is away from the origin. It's not going to be touching the zero. And why it is that? Because when we say y is inversely proportional to 1 over x, so x value cannot be 0, because if x value becomes 0, it will be undefined. So it never goes close to 0. So it's always passing away from the 0, and it is showing that one entity is at maximum, the other was at low. And when the other is at maximum, see, other is at low. So this curve is giving the trend of the inverse proportion. And I hope that you got the idea of the inverse proportion as well now. And we have already discussed the direct proportion. And so let's conclude this chapter. And the next we will be doing is the linear graphs and the simultaneous equations chapter. So thank you very much.